I have 26 too.
I have 28. 28.
Just a moment.
Which one are you running?
The developer.
Oh.
That's 26.
I'm stable.
Does anybody see anything that I did wrong?
It seems like it might be a version difference.
That's weird.
I love this.
Why is the degrees of freedom change?
Oh, I think the reason why it's 26 is because it's for both models.
No, but it's. What version am I using? Anybody know?
Unstable one.
The developer.
This is the developer version that I'm using.
Stable is not working. I'm using this first settings.
Did I not? I thought I saved it. We're going to answer this question the right way, I guess. Alternatives?
I think it's the second one, right?
Oh, this does actually bring up something that is worth mentioning. For reasons that I'm not totally sure about, whenever you do a multi-group model, it doesn't necessarily save these grouping variable things, and so sometimes you have to redrag those variables over. Just beware.
So I have a question.
Wait, I'm still thoroughly answering this question.
Like it doesn't get that you have data there.
26 in this.
Why is that?
Now, to some extent, I don't care, right? Because it's all about relative fit at this point. The amount that the degrees of freedom are going to change, and the change will be the same. Why one says 28 and the other says 26? I don't have a great answer for that.
You probably have your observed statistics were probably 98 earlier. When we used different versions before, you had more observed statistics.
Which is actually correct then?
I don't know. I'd have to count up the number of parameters and figure out the degrees of freedom that are possible, and that's not something that I'm used to doing. So it would take me a little time. Jose talked with Andreas or whatever, and it does have to do with that whole mean thing and what psychologists count as degrees of freedom versus statisticians. So I don't fully understand it. I'm not going to pretend to understand it.
Okay.
We don't care is what I can be relatively confident in saying. Okay, there was another question. Sorry.
Are we supposed to be noting the negative 2 log likelihood or the log likelihood?
The negative 2 log likelihood.
Okay, I have 4.
Yeah, I think you'd had it as well. You just wrote the wrong one.
Are you saying I did the wrong thing?
Mm-hmm.
I'm saying saying it was Joanna.
Oh. 4369. Thank you.
Distracted.
That was a very polite way of telling me that I was wrong. Thank you for that. That's how it's done. All right. Yes?
So the unconstrained model has both of the models.
Right.
Okay.
This unconstrained model, the fit is literally the fit of the one model plus the fit of the other. Because there's nothing overlapping in them, it's literally the sum of those two fit statistics. I don't know what version I'm in. I don't care anymore. They've really sucked the life out of me by having this degrees of freedom issue.
I think you're the newer unstable version because that's the one that I have, and I have the same degrees of freedom. So. I want your opinion.
You know, my kids in school, that's what they do. Like, they've got all these different hand signs for, like, if you agree with somebody, if you make a connection. It's different. Okay, so we're to the finale here. This is great. The question is, are the measurement models the same? So how do we add constraints? Well, the first thing that I would do is, instead of comparing this variance to this variance, I'd rather compare this path to this path. So I'm actually going to make this where I fix it to 1. So I can free that other path. We could have done this way back in the CFA, but I forgot.
You fix both variances on both, or okay.
Not sure. Sorry. I don't need to do factor. Yeah, variance around the factor.
Oh yeah. there
So
we go.
what I did is I fixed this variance to 1. And I fixed this variance to 1. Then I freed this path and this path. Remember, this is just our other way of estimating a CFA. But now I can compare the factor loadings directly instead of the variances in one hand and factor loadings on the other. Now, how do we constrain two things to be the same? We label them the same. And so this now, and let's make sure, let's make sure that our fit is the same. Theoretically, our fit should not have changed just by swapping that around. 4369,
Oh, right, because you
4369.
constrained 2 and freed 2.
Right.
So nothing.
And we've changed nothing. It's just a different estimation for a different set of things that it's estimated. Okay? So now we are going to do a 4 degree of freedom change test. So what I want you to do is simply, you can just remove that apostrophe on all of these. So now it's not lambda 1 and lambda 1 apostrophe, it's lambda 1 and lambda 1, lambda 2 and lambda 2. And so because of that, you are now saying that these two things are the same. The factor loadings are the same, and that's definitely visible. You can make sure that the numbers are the same. And now, we look. Negative 2 log likelihood, 4376. Degrees of freedom, it should be 30, or we should be getting more, so it should be 32. This says 28. Oh, but I got, this was from my other version, right? Or, sorry, there's
We
a,
have 26 and 30.
now we have 28, so the other model should have 24. If I were really doing this, I would double check that all of this just worked out, but we're out of time. So,
Yeah, I do too.
but I was switching versions, and I think that that's why those numbers are wrong. So we had 24. We picked up 4 things because now it's not estimating 4 paths and 4 paths. Now it's just estimating 4 paths that are the same. And so the question is, so that's a difference of 7 for 4 degrees of freedom. Is 7 chi-square unit change difference significant with 4 degrees of freedom? No. So what does that tell you about this model?
It's not significantly worse than.
Talk to me more like in English with less statistical terms about language and about the lunch groups. Yeah.
So the factor structure between students in verbal and non-verbal are equivalent, or similar enough that they're not statistically different.
Yeah. I like that. Not statistically different. Okay, that's it for today.
What do we call this model that we just run instead of unconstrained?
Well, this would be
Measure.
a measurement constrained or something like that. And if we had other things in the model, which we do, we could keep going. We could say, well, the means are allowed to be different. Notice that the mean for the 0 group, the non-lunch group, is 8.48, and this mean is 7.37. So you could constrain those to be the same. And build off of this. Let's do it. This is so cool. I bet you this is significant. I bet you. That's 4416. 4416. Which do I compare it to? The unconstrained or the constrained?
Unconstrained.
Measurement. Whatever one's better?
The constrained. Because that is what I just came from. The constraints were justified. So now we're going to keep going. 4416.
Oh, the unconstrained assumes that the two groups are different. The
Right.
constrained, so because it was not significant, the constraint is like, yeah, that's just one group. It's not
All right.
two.
We really got to go. There's a job talk for the ADP candidate. Invite you to come to. It's JC, what is it, C or D? All right, goodbye.
My grad student panel.
Yes, I have to run to my office, then run to the bathroom, and grab a snack, but I'll be there.
I have cookies and like brownie stuff that I'm bringing for you guys, so.
But I will be there.
Sweet.
I'm not gonna be able to talk.
No, do what you gotta do.
I'm going to that. She teaches babies how to apply to grad school. But then I'll be at the